A K4 cab was not a workplace. It was a partnership. The engineer on the right side controlled the throttle, the reverser, the brake valves, and the locomotive's progress down the track. The fireman on the left side controlled the boiler, the fire, the water, the steam pressure that kept everything else alive. Together, they kept a 425-class locomotive moving across the most demanding passenger railroad operations in America: the Broadway Limited, the Congressional Limited, the General. The premier trains of the Pennsylvania Railroad ran behind K4s for 40 years, and behind the K4 crews who knew their locomotive better than most people know their own families. This is what it was like to actually drive the locomotive that defined American steam practice. The procedures, the skill, the coordination, the relationship between two operators and one of the most refined steam locomotives ever built. The art that the F unit replaced. The Pennsylvania Railroad. K4 Pacific was a two-person locomotive. The engineer ran the train, the fireman ran the boiler. Neither position could be done by one person. Neither position could be filled by an untrained operator. Both positions required years of apprenticeship before a railroad would entrust either job to a regular employee. An engineer's seniority on the Pennsylvania Railroad was measured in decades. Most engineers spent 10 to 15 years as firemen before promotion. Most senior K4 engineers had operated steam locomotives continuously since World War I. The skills accumulated over those careers were not theoretical. They were tested every day on the road by the consequences of getting them wrong. The K4 was the locomotive on which most Pennsylvania Railroad engineers spent the majority of their careers. The class served from 1914 through the mid-1950s. Engineers hired in the 1920s or 30s operated K4s for 30 or more years before dieselization ended the era. The relationship between crew and locomotive was unlike anything that exists in modern railroading. What it was like to drive a K4 is the story of that relationship, and the operational skills that have largely disappeared from American railroading since the K4 era ended. The engineer's controls on a K4 were positioned along the right side of the cab. The throttle was the dominant control, a large brass quadrant that controlled the flow of steam from the boiler to the cylinders. The throttle moved through a continuous arc rather than discrete positions. The engineer modulated steam flow by feel rather than by detent. Operating the throttle was not a binary task. The throttle had to be opened gradually as the locomotive accelerated. Too aggressive an opening and the locomotive would slip, the driving wheels losing traction against the rails, spinning helplessly while the train fell behind. Too conservative an opening and the locomotive would labor, burning coal and water without producing the acceleration the schedule demanded. The reverser was equally important and even less intuitive. A long horizontal lever extending forward from the engineer's position. The reverser controlled when in each piston stroke the valve gear admitted steam to the cylinders. Moving the reverser forward, toward the long end of its arc, admitted steam for a longer portion of each stroke. Moving the reverser back, toward neutral, admitted steam for a shorter portion. The reverser position was called the cutoff. A full forward cutoff, also called full gear, admitted steam for nearly the entire piston stroke. Maximum starting power. Maximum steam consumption. A short cutoff admitted steam for only the first portion of the stroke. The trapped steam then expanded against the piston for the remainder of the stroke. Lower instantaneous power. Far higher thermal efficiency. The engineer adjusted the reverser continuously throughout the run. Full gear when starting. Progressively shorter cutoff as speed increased. The skilled engineer found the cutoff position that produced exactly the steam consumption the fireman could sustain while maintaining the speed the schedule required. This balancing act defined steam locomotive operation. The engineer commanded the locomotive's behavior through throttle and reverser. The fireman determined what the locomotive could deliver through boiler management. The two operators had to coordinate constantly, through tactile awareness of the locomotive, through the steam pressure gauge, through verbal communication, and through the unconscious cues that experienced crew partners developed over years working together. The brake stand on a K4 used the same Westinghouse air brake system that every other American passenger locomotive of the era used. The automatic brake valve controlled the train brakes. The independent brake valve controlled only the locomotive brakes. The application and release of brakes was a learned skill. Too aggressive, and the train slack would run together violently, snapping couplers and damaging cars. Too gentle, and the train would not stop in time for signals or station stops. A K4 at the head of a heavy passenger, consist with the Broadway Limited's reputation on the line, required an engineer who could thread the needle on every variable. Throttle opening, reverser cutoff, brake application timing, all while maintaining schedule on a railroad that valued punctuality more than almost any other operating metric in the world. But the engineer could only command what the fireman could deliver. And the fireman's job was where the real physical work of steam railroading happened. The fireman's job was to keep the boiler producing steam at the rate the engineer was consuming it. This sounds simple. It was not. A K4's boiler consumed coal and water at rates that depended on the engineer's throttle and cutoff settings, the train's weight, the grade of the track, the wind conditions, and the quality of the coal being burned. At cruising speed on level track, a K4 hauling a heavy passenger consumed roughly 3,000 pounds of coal per hour and approximately 1,000 gallons of water. On grades or during heavy acceleration, the consumption rates could double. The firemen had to anticipate these demands and adjust the firing rate continuously. Until the late 1920s, the firing was done entirely by hand. A scoop shovel. A continuous physical effort. The firemen moved coal from the tender behind the cab into the firebox at the front of the cab, shovel by shovel, for the entire run. A typical passenger run between Pittsburgh and Harrisburg involved the firemen shoveling between 8 and 12 tons of coal in a single shift. The technique of firing was not random. The firemen placed coal in specific patterns across the firebox grate. The fire had to burn evenly across the entire grate area to maximize heat transfer to the boiler tubes. Concentrating coal in one location produced cold spots elsewhere and dramatically reduced boiler efficiency. The firemen learned to throw coal accurately to specific zones of the firebox from 20 feet away, while the locomotive was bouncing and swaying at 60 miles per hour. Beginning in the late 1920s, the Pennsylvania Railroad began retrofitting K4s with mechanical stokers, augers that fed coal from the tender directly into the firebox. The fireman's physical labor was reduced substantially, but the skill required was not. The mechanical stoker had to be controlled to match steam demand. Too much coal, and the fire would be smothered. Too little, and steam pressure would fall. The fireman watched two critical indicators constantly. The water glass, a vertical tube showing the water level in the boiler. The steam pressure gauge, showing the pressure at which the boiler was operating. The water level had to be maintained within a narrow band. Too high and water would be carried over into the cylinders, causing potentially catastrophic damage. Too low, and the firebox crown sheet could be exposed to the fire without water cooling, leading to immediate boiler failure. Water was added to the boiler through injectors, devices that use steam pressure to drive water from the tender into the boiler against the boiler's own internal pressure. The firemen operated the injectors continuously throughout the run, balancing water input against water consumption to maintain the correct boiler level. Each injector had its own technique. The injector handle had to be opened to the correct position. The water valve had to be coordinated. The injector itself could fail to start or fail mid-operation, requiring immediate diagnosis and correction. A fireman who could not start a failed injector quickly could not be trusted with revenue service. Beyond the immediate operational tasks, the fireman was responsible for an enormous amount of inspection and ancillary work. Checking lubricators, monitoring the smoke from the stack for fire condition feedback, watching for trackside signals on the left side of the locomotive that the engineer could not see, operating the bell, watching for hot boxes and other equipment problems on the train behind. The engineer and the fireman were not two operators doing separate jobs. They were one crew running one locomotive, and the coordination between them was the entire point. Steam locomotive operation depended on continuous coordination between engineer and fireman that had no parallel in any other industrial workplace. The engineer knew what the locomotive was about to demand: the grade ahead, the speed restriction approaching, the signal he had just acknowledged. The fireman had to prepare the boiler for those demands before they arrived. A skilled crew worked by anticipation rather than reaction. The engineer might call out the upcoming track conditions to the fireman as they approached. The fireman might adjust the firing pattern before the engineer changed the throttle. The injectors might be started in anticipation of a grade rather than after steam pressure had dropped. Crews that worked together regularly developed working relationships that took years to mature. A senior engineer might request a specific fireman for premier passenger runs. The two operators developed an unspoken communication, hand signals, brief verbal cues, the shared understanding of how the locomotive responded under various conditions. The skill of the crew determined the performance of the locomotive. A K4, hauled by a competent crew, could meet its schedule reliably across the most demanding routes the Pennsylvania Railroad operated. A K4, hauled by an inexperienced crew, could lose time on the same routes. The engineer's throttle work mismatched to the fireman's boiler management, the locomotive starving for steam exactly when steam was needed most. The Pennsylvania Railroad recognized this skill differential explicitly. Premier passenger trains were assigned to senior crews. Apprentice firemen learned on local freights and switching assignments, where errors would cost time rather than reputation. The progression from apprentice fireman to senior engineer took 15 to 20 years. The progression was earned through demonstrated competence on increasingly demanding assignments. An engineer who reached the top of the Pennsylvania Railroad seniority list, qualified to operate K4S on the Broadway Limited or Congressional Limited, held one of the most respected industrial jobs in America. The pay was substantial by working-class standards. The job security was exceptional. The social status within the railroad community was elite. But the job also demanded total attention for the duration of every shift. There were no automated systems. There was no autopilot. There was no relief from the cognitive load that managing a steam locomotive at speed required. Engineers who could not maintain that attention level were not promoted to premier assignments. Engineers who lost the ability to maintain it through age or illness were rotated to less demanding service. The K4 era did not end suddenly. The Pennsylvania Railroad kept K4s in service through the early 1950s, even as diesel locomotives became dominant. The last K4 was retired from regular service in 1957. But the experience of operating a K4 ended much earlier for most Pennsylvania Railroad engineers. As diesel locomotives took over premier passenger service in the late 1940s and early 1950s, K4 assignments became less prestigious. The premier trains went diesel. The K4 was relegated to secondary services. Engineers who had spent their careers as K4 specialists transitioned to diesel operation in the late stages of their careers. Some welcomed the change. The cleaner working environment, the simpler operation, the reduced physical demand on aging bodies that had spent decades in steam cabs. Others mourned what they had lost. The skill differentiation, the pride of mastering a complex thermodynamic system, the relationship with a fireman partner that had developed over years of shared work. The diesel locomotive was easier to operate, and that ease was for the engineers who had been the elite operators of the steam era, the loss of everything that had made the job theirs. The K4 was retired with most of the railroad practice it had defined. Hand firing had ended years earlier. Mechanical stokers had reduced the physical demand. The two-person crew structure persisted through dieselization but had lost its operational necessity. By the 1960s, the entire culture of two-person steam crew operation was history. Two K4s survive in preservation. Neither has operated under its own power in over half a century. The locomotives are physically intact. The procedures and skills required to operate them are not. The handful of engineers who could still run a K4 at speed without supervision are now in their 90s. Within a decade, the operational knowledge will exist only in documentation. And in 2023, the T1 Trust began construction of K4 number 5550, the first new K4 in nearly a century. The locomotive is being built using original Pennsylvania Railroad blueprints. When it is completed, it will be operated by engineers who have spent years studying the same documentation that the original Pennsylvania engineers learned through apprenticeship. The skills can be reconstructed from records. The crew partnerships that defined the K4 era cannot. What it was like to drive a K4 was not just an operational experience. It was a way of life, a craft that required years to learn and a lifetime to master. A partnership between two operators and a locomotive that demanded everything from all three. The F unit ended that way of life through superior economics. The diesel locomotive replaced the craft of steam operation with the profession of locomotive operation. Both have their merits. They are not the same job. The K4 era was the peak of one of the most demanding industrial crafts in American history. The locomotive was the standard that defined American steam practice. The crew was the standard that defined American steam operation. The combination produced premier passenger service that no diesel locomotive could match for sheer mechanical drama, and no diesel locomotive ever needed to. Driving a K4 was the experience of operating American railroading's most refined steam locomotive at the peak of steam railroad practice. The engineer and the fireman. The throttle and the firebox. The continuous coordination that turned coal and water into premier passenger service across the most demanding routes in American railroading. This is the final video in our From the Cab series. 4 locomotives. 4 different experiences of operating significant American railroad machines. The Union Pacific Big Boy and its 2-person crew managing a million-pound articulated steam locomotive. The Pennsylvania Railroad GG1 with its electrical multiple unit controls. The EMDF unit consolidating 4 locomotives into a single cab. And the K4 Pacific demanding the most refined craftsmanship of any locomotive in this series. This series is the companion to our What's Under the Hood series on the engineering inside each locomotive. The 8 videos together tell the complete story of how 4 locomotives defined American railroading, through what was mechanically inside them, and through what it was like to actually operate them. All links are in the description. Subscribe so you do not miss what we cover next. There are more locomotives. There are more engineering stories. There are more operational legacies. American railroading produced some of the most consequential industrial machines of the 20th century, and we will keep examining them, one locomotive at a time.